Let's look at an insurance policy example with expected value. An insurance company charges $600 for a policy. Based on past data, an average of 1 in 50 policyholders will file a $5,000 claim. An average of 1 in 100 policyholders will file a $10,000 claim. An average of 1 in 200 policyholders will file a $30,000 claim. Let's create a probability distribution for the amount of money the company pays out per policy. So we've got two rows here, one for the payout and one for the probability of that payout. So let's start with the first thing that was listed. It said based on past data, an average of 1 in 50 policyholders will file a $5,000 claim. Let's assume that if that's who files the claim, let's just assume the payout. So the payout is $5,000 and the average is 1 in 50, so the probability will be 1 out of 50. The next payout, an average of 1 in 100 policyholders will file a $10,000 claim. So $10,000 goes out on average 1 out of 100 times. And the last thing they mentioned was that a $30,000 claim will be paid out an average of 1 in 200 policyholders. So 1 out of 200 would be the probability for that scenario. Now, notice I've left off one part of my table. There's nothing else that's described here, but I've left something out. And if we look at our probabilities closely, 1 out of 50 plus 1 out of 100 plus 1 out of 200, that does not add up to 1. We're missing a lot. So why isn't it adding up to 1? Well, think about an insurance policy. Many of us have insured maybe a car or a home in the past, and when you purchase an insurance policy, you purchase it in case something happens, but you hope that nothing happens. So the people making the claims have had something happen, but there's lots of people who purchase a policy who never have to use it. So the last situation here that needs to be looked at is when there is no payout. So someone has purchased the policy, but they don't have a car accident and there is no payout. So in many cases, the insurance company is not going to have to pay anything. Now that's not described, but it should be kind of implied that there is always the chance that they don't have to pay the person anything. Now to calculate the probability, which isn't listed, we want to take advantage of the idea that 100% of things happen in this probability distribution. So I can take 100%, which is the same thing as 1, and I can figure out this remaining probability by saying 1 minus 1 over 50 minus 1 over 100 minus 1 over 200. Because whatever is left over, if I take these other probabilities away from 1, should be what I need in my last probability of not having to pay anything out. Now, you could get a common denominator and do this by hand, this calculation by hand, or you could just simply use your calculator and go 1 minus 1 over 50 minus 1 over 100 minus 1 over 200. Remember, the fraction, just use a division symbol in your calculator to calculate that. So if I do that, 1 minus 1 divided by 50 minus 1 divided by 100 minus 1 divided by 200, I get 0.965. So basically, there's a 96.5% chance that somebody doesn't file a policy. Now we do want to write that as either a decimals or fraction. Since I used my calculator, I'm going to write the decimal down. If you got a common denominator and worked that out, you would have gotten a fraction there. Either way, we can, now that we have the entire probability distribution put together, I can go ahead and find the expected value. So I'm going to organize the information with the multiplications for every payout and the corresponding probability, and then add them together. So that's why the table is so helpful, is because we can see all of that we need to do right next to each other. So I'll write that down. 5,000 times 1 over 50 plus 10,000 times 1 over 100 plus 30,000 times 1 over 200 plus 0 times 0.965. All right, multiplying that all out, as we've talked about before, multiplying, adding, all with your scientific calculator makes it really nice. We should get a value of $350. So think about what this means. $350. That is the amount that on average the company pays out for each policy. Now that's if they do a lot of policies, okay? So for lots of policies, a large number of policies, because we're talking about the law of large numbers here, that's what makes expected value work. For a large number of policies sold, the average amount paid out by the insurance company is $350. That's their average amount. So we have to talk about that being an average, and it's per policy. Let me put that in. It's $350 per policy. It's important that you recognize that it's for each individual policy. That's what they're going to pay out. Now, what's the company's expected net revenue, though, for each policy? Now, there's one piece of information we hadn't looked at yet in this scenario, and that was the very first sentence. Up here it said that the company charges $600 for a policy. That's what they charge everyone. Everyone they charge $600 to. So they're taking in $600, and then on average they're paying out $350. So they take in $600 and pay out on average $350. So the net revenue would be the difference between those two. 600 minus 350 is $250 per policy. They are basically keeping $250 per policy on average. So if the company sells 200,000 of these policies each year, how much can they expect to make on average? Well, for each policy, we had $250 coming in on average. Again, it's not exact, but it's the on average what we do if we sell many, 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 many policies. If we multiply that by 20,000, we actually find that they're making $5 million a year from a policy like this, which is a pretty good chunk of change. Insurance companies count on probability. They have people that they hire to examine lots and lots of data of what happens. Whether if they're doing life insurance, they look at how frequently people get various types of diseases and cancers, and to give an estimate of how long people will live based on their health. They will look at all of this to create these types of probability distributions and figure out their expected payout and base how much they want to charge people for an insurance policy on that. They're counting on selling many, many, many policies so that they get this average to work out, so that they know that they will be able to make a profit. Everything is based on probabilities. Another example involving insurance, extended warranties. An electronics retailer estimates that 4% of a certain product that costs $200 to replace will fail after the original warranty, but within 2 years of purchase. They want to offer a 2-year extended warranty that on average nets them $5 per policy sold. And I'm saying nets, so that's what they want to keep. Determine how much they should charge. Well, to work out how much they should charge, we need to figure out how much on average they would pay out in this scenario. So let's create a probability distribution for the amount the company pays out for each extended warranty sold for this product. Well, there's really two things that can happen when they sell an extended warranty. The product is just fine for those 2 years, so the product is fine, or the product fails. So let's first consider the product failing. Okay, if the product fails, the company is going to have to pay out $200 to replace that product. That's going to happen, according to the problem, about 4% of the time. 4% of the time. And when we write a percent, because we're going to calculate it into a probability distribution, we generally make it into a decimal, so 0.04 for 4%, because we are going to be calculating with it. Now, the other thing that could happen is that there is no failure of this product, in which case the retail company pays out zero. They don't have to replace the product. And to figure out the corresponding probability of that, just think about how it's the opposite of the failing probability. So we can look at the complement by subtracting. 1 minus 0.04 would give us the corresponding probability of not failing, which is 0.96. So the probability of not having a failure, in other words, the probability of having to pay out zero, is 0.96. Let's find the expected value of the payout. So because we've organized the information, we can grab them and do the multiplication and then add directly. So I have $200 with a probability of 0.04 plus $0 with a probability of 0.96. Adding that together, I'm going to get $8. 200 times 0.04 plus 0 times 0.96 is $8. Now, think about what this means. On average, for many, many extended warranties sold, the company is going to pay out $8 per warranty sold. Again, this is over the course of selling many, many warranties. We are taking advantage of the law of large numbers. So this is what would happen in the long run in thinking about selling many, many policies. They would, on average, pay $8 per policy. Now, remember what the company wanted to do was they want to, on average, net themselves $5. That means they want to have $5 left over what they charge the person. Well, if they're going to end up having to pay out $8, they want to charge $8 for sure, but then they also want to charge the $5 on top of that to actually make that $5 in terms of net profit. So the $8, they charged $8, that would be breaking even, but they want a profit of $5, so they're going to charge 8 plus 5 or $13. So the company should charge $13 for the warranty.